Alright, this is quiz 13. Study guide. Alright, number 1 says find the sum of the measures of the angles of the figure. The sum of the measures of the angles of the figure. That's n minus 2 times 180, where n is the number of sides. So if you count the number of sides in that shape, there's 7 sides in that shape, so 7 minus 2 times 180 will give you the sum of the angles for that shape there. So that's 5 times 180, 900 degrees. Number 2 asks, what is the sum of the angle measures of a 36gon? Same formula. N minus 2 times 180. And a 36gon has 36 sides. So it's going to be 36 minus 2 times 180. $61.20. In number 3, you're told that the sum of the angle measures of a polygon with S sides is 2520. Find S. Alright, so they're using the letter S in replacement of the letter N. You can continue to use the letter N. What they're telling you here is that N minus 2 times 180, in this case, is equal to 2520. They're telling you what the sum of the angles is. Alright, so, and they're asking you to solve for n. So in this case, the easiest way to solve for n is to divide both sides by 180. And on the left, you're going to have your n minus 2 equals 2520 divided by 180. That's 14. And if you add 2 to both sides, then your n is equal to 16. So that shape has 16 sides. Number 4 asks, what is the measure of one angle in a regular 25gon? One angle in a regular 25gon. So what you do in this problem is you take n minus 2 times 180 and you find out the sum of the angles in that 25gon. And then you divide it by 25. Okay? So if you take n minus 2 times 180, it's a 25gon. So you've got 25 minus 2 times 180. So 23 times 180 is 4140. 4140 is the sum of the angles for a shape with 25 sides and 25 angles. So if you divide that by 25, it'll give you each angle measure. And that's 165.6. Number 5 is the same type of problem. A road sign is in the shape of a regular heptagon. Heptagon has how many sides? Good. Hepta is 7. What is the measure of each angle on the sign? So we're going to find the sum of the angles, and then we're going to divide that by the number of angles, which is 7. So we got 7 minus 2 times 180 is 900. And we're going to divide that by 7 to get each angle measure. 128.57, so we're going to go with 128.6. Are you good, Lonnie? Alright, number 6. Alright, in number 6, you're asked to find the missing values of the variables. So, we need an x and we need a y. And we're going to start with this y right here because these two angles are a linear pair and they sum 180. So 124 plus y equals 180. So if you subtract 124 from each side, then your y is equal to 56. So if this y right here equals 56 degrees, now you have 3 angles out of 4 in a quadrilateral. Okay? A quadrilateral's got 4 sides. So the sum of the angles in a quadrilateral is equal to 4 minus 2 times 180, which is 360. The angles in this 4-sided shape have to sum 360. So if you subtract the 3 yellows that are given, if you subtract your 56 and your 65 and your 125, what's left is what x is equal to. Which is 114. In number 7, find the value of x. The diagram is not to scale. You have a shape there with 5 sides. So the sum of the angles is going to be equal to n minus 2 times 180. So first thing you're going to do is take 5 minus 2 times 180. And 3 times 180 is 540. So the 5 values or terms that represent those angles have to sum 540. So if we combine the x's first, you've got a 2x plus a 2x. So you've got 4x. And now we're going to combine all the whole numbers. And don't forget about the 90-degree angle down there that's represented by that symbol. So highlight that, mark it, put an arrow, asterisk next to it. Don't forget that angle. Start with that angle. So you got a 90 plus a 148 plus the 10 plus the 112. Alright, so you got 4x plus 360 has to equal 540. If you subtract 360 from each side, then your 4x equals 180. And if you divide by 4, then your x in this case is 45. Alright, so the 4x was a combination of your like terms, your two x's, and the 360 was a combination of the 90, 148, 10, and 112 in that picture. Number 8. The sum of the measures of two exterior angles of a triangle is 255. The sum of the measure of two of the exterior angles in a triangle is 255. In all polygons, the sum of the exterior angles, one at each vertex, is 360. Well, they're giving you the sum of two of them in a triangle. So if you take 360 and you subtract the sum of the two angles that are given, it'll tell you what the third angle is equal to, the third exterior angle. So 360 minus 255, 105. The third exterior angle in that triangle is 105 degrees. Number 9, how many sides does a regular polygon have if each exterior angle measures 20 degrees? How many sides does a regular polygon have if each exterior angle measures 20? Well, all the exterior angles have to sum 360. And if it's a regular polygon, they're all the same. So if you divide 360 by 20, it's going to give you the measure of each, which is 18 degrees. Number 10. I'm going to draw the only part of number 10 that really matters. Jewelry box is in the shape of a regular pentagon. It is packaged in a regular box as shown here. The box uses two pairs of congruent right triangles. You've got this picture going on. And this pentagon goes down here. You've got a variable right here and a variable right here, and you're told that these are right angles. What you need is the value of x. If you look at these three angles right here, these three angles form a straight line, so they're a linear group. Okay, they have to sum 180 degrees. So if you knew this middle angle in here, if you knew this yellow angle, it's supposed to be yellow angle. If you knew this yellow angle measure and you added it to 2x and you made it equal to 180, you could solve for x. Well, this yellow angle is one angle in a regular polygon or a regular pentagon. So if you take 5 minus 2 and multiply it by 180, you're going to get 3 times 180, which is 540 degrees. That would be the sum of the 5 angles in this regular pentagon. Since it's a regular pentagon, they're all the same. So if you take your 540 and you divide it by 5, it's going to tell you what each angle in the pentagon measures. So 540 divided by 5 is 108. So each of these yellow angles is 108 degrees. Now, with that information, you can write an equation and solve for these x's. So your x plus your 108, that would be 2x plus 108, has to equal 180. So if you subtract 108 from each side, then your 2x is equal to 72. If you divide by 2, then your x is equal to 36. Alright, then 11 through 16, those are all going to be simplifying radicals, which we did right before the break. So number 11, square root of 98. Alright, probably want to review your notes from before Thanksgiving, but when you're simplifying radicals, you're going to take this number under the radical and you're going to divide it by perfect squares until you find the largest perfect square that goes into 98 evenly. And that's going to be the square root of 49 times the square root of 2. To simplify that, the square root of 49 is equal to 7 times the square root of 2. There's your simplest form. Number 12 asks you to simplify the square root of 700. The largest perfect square that goes into 700 evenly is 100. So the square root of 100 times the square root of 7. 100's a perfect square, so this simplifies to 10 radical 7. Number 13. You're simplifying the square root of 144 a squared. They're both perfect squares, but if you break this apart, the square root of 144 times the square root of a squared, in simplest form this would be 12a. The square root of 144 is 12, and the square root of a squared is a. In number 14, you're simplifying the square root of 108. C to the fourth d squared. So your first step is to break this apart. And we're going to break it apart into the square root of 108 times the square root of c to the fourth times the square root of d squared. Simplify the square root of 108, finding the largest perfect square that goes into it evenly. And that is 36. 36 goes into 108 3 times. So the square root of 36 times the square root of 3. Now, the square root of c to the fourth, that's a perfect square. It's equal to c squared. The square root of d squared is a perfect square, and that's equal to d. The square root of 36 is equal to 6. So now you take your three terms that are not under the radical, the 6, the c squared, and the d, and you combine those. That gives you 6c squared d times the square root of 3. There's your simplest form. Number 15, square root of 8. c squared, d to the third. Again, you're going to break it apart. Square root of 8 times the square root of c squared times the square root of d to the third. Your 8 simplifies to the square root of 4 times the square root of 2. Your square root of c squared is a perfect square, and that's equal to c. Your d to the third simplifies to the square root of d squared times the square root of d. The square root of 4 is equal to 2, and the square root of d squared is equal to d. So now you're going to combine everything that's not under the radical, which is the 2, the c, and the d. And then you're going to combine everything that is under the radical, which is the radical 2 and the radical d. So here's what it looks like in simplest form. You got 2cd times the square root of 2d. There's your simplest form. Number 16, you're simplifying the square root of 80. C to the sixth, d to the fourth. Again, you're going to break it apart. It's the square root of 80 times the square root of c to the sixth times the square root of d to the fourth. 80. The largest perfect square that goes into 80 is 16. So 80 is equal to the square root of 16 times the square root of 5. The square root of c to the sixth, that's a perfect square, and it's equal to c to the third. The square root of d to the fourth is a perfect square. It's equal to d squared. And the square root of 16 is a perfect square, and it's equal to 4. So now you're going to combine everything that's not under the radical. You got a 4, a c to the third, and a d squared. So outside the radical you got 4, c to the third, d squared. And under the radical you have the square root of 5. There's your simplest form.